Good morning, ladies and gentlemen of the Algebra 2 Honors. We have some problems to work on today. Solving exponential equations. So I want you to look at problem 17 and think about it for a second. One thing that I don't know if you've heard, have you ever seen a problem like this before? There's a very famous problem, or a very famous story, historical anecdote, I think it's really a legend, about this type of situation here. You ever seen something like that? Yeah, the grain, that's it. So Chloe remembered it. The grain of rice. So what happened is that some person had an opportunity to present an option before a king. Well, king, in return for my service, you can give me like 2,000 bushels of wheat, or you can give me on the first day during the entire month a grain of rice on I think it was 1 square of the chessboard or something like that. And then on the second day you give me 2 grains of rice on the second square of the chessboard. Then the third day 4 grains of rice, 8, 16, 32, 64, 128, 256, 512, 10, 24, 2048, and then it's 40, 96 or something like that. It's just double every day. And how's the story end up?
You just have a lot more than.
Yeah, then the king didn't have enough rice in his entire kingdom to fill all the granaries to deliver all the rice by the end of the thing. And this is a similar sort of thing here. It's the same type of exponential relation. So somebody, you have an idea of how to do this one?
Isn't it, there's like an exclamation mark in the calculator, and isn't that what it is?
Okay, you're thinking of factorial, right? Yeah.
Isn't that what that is?
I don't think it's that, but let me show you what that is in the calculator, just to show you what she's talking about, because that's in factorial. That's one thing in pre-calculus we're going to do next year when we talk about the binomial expansion. Okay, which is sort of at least tangentially related to what we're talking about, because this is an expansion also. But where you see that is here, just to show you what she's talking about. So there's a thing in discrete mathematics we call it, which is called factorial. And basically factorial, if you have something called 3 factorial, which is like a 3 with an exclamation point, that's going to be 3 times 2 times 1. And then you start to get higher numbers, it's harder to calculate. So if you want 8 factorial, which is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, you can go to math and you go here. I'm trying to think of where, yeah, there it is, that exclamation point. So go to 4, 8 factorial is, that's what it is, okay? But this particular exponential function is not that. Okay, this is the same thing we've been doing. Any ideas on this yet? Okay, the value, so, pardon me? Yeah, so what it is, basically it's the same type of equation we've been talking about. A of t equals a sub 0 and times the base to the power of t. Okay, it's the same thing we've been talking about. So in this instance, what is our first thing going to be here? What is A of t? 20,000, right? And A sub 0 is our initial value. What's our initial value? So this is our initial value. And then what is our base? Double, right? Double, so 2 to the power of t. And so this is what, so really that's all there is. And so to me, the challenge in this one is, it doesn't seem like there are a whole lot of numbers to work with, does it? Well, they're all there, aren't they? They're all there. So we can come to this and go to 20,000 equals 0.01 times 2 to the power of x. And from here, what can you do? One thing you can do is you can go to the table view and you can see, can't you, when this thing is coming up to, so when is it going to be? Yeah, about after 20 days or right before 21 days. And if you want more exactness to it, you can flesh that out by graphing. Okay, we know what the time is already, having looked at the table view. And we got, some of you are getting pretty good at setting these windows. So you have this looking thing here. Second trace 5, enter, enter, enter. So 20.93 days, so within 21 days. So on which day? On the 21st day, right? So that's that one. Okay? What I want you to do is go to problem 18, and I want you to work that one out. I'll choose somebody for this one. And probably today on these one, we'll probably go through problem 20. That's it. Here to give you you can read pretty well on the paper and everything. The exponent is. It's okay to talk to each other, but I see most of you are getting your calculator out, working on something. Okay, today we have problem 18. Should I bring the Lexi? All right, Lexi, what do you think about this?
Seniors, if you are going on the field trip, you need to come to the cafeteria now. They're fixing to leave.
So where'd you go?
Oh, well, I wrote up here,
Okay, which was,
10,000.
like that?
Equals 3,400.
Okay.
That's embarrassing.
And then I added also 1.03 to the power of t.
Oh, T, okay. I don't know what's happening at the back of the classroom there or something.
She dropped her.
I dropped my pencil bag.
Oh, pencil bag.
Yeah,
Pencil.
you got
We had a
the
pencil
pencil
bag event back here. Okay. All right, we're gonna work through this. All right, go ahead. Then,
And then also y equals.
then your this is called your function editor is what it's called. And it was 10,000 you said? And then it was like 3,400, did you say?
Oh,
Like this? Is that it?
Yeah.
Okay. And I don't know what, we left the window from earlier. It looks like it, window might be enough, right? Because we had 25,000, so. Okay, not quite enough, is it? So what did you adjust your X max to?
I don't know, because I erased it. 40.
40? Okay. So is that you got 36.497. 36.497, and that's what? Years, right?
Yes.
Years. So about 30 and a half years. 36 and a half years. Yeah. 36 and a half years. Like that, that's what you had for it?
Yes.
Okay. All right. Not too bad, is it? Go ahead and do problem 19. Are you not talking to each other because it's too easy for words?
Yeah.
It's too easy? Or is it just too early in the morning?
Some Monday.
It's a rainy morning?
It's a rainy Monday morning.
Rainy Monday morning.
Last Monday morning.
Yes.
Okay.
In 1 week, I'll still be asleep.
Oh, yes, you would. All right. Yeah, see, I miss you.
Did you get that? What did you say?
Huh?
What did you
What
say?
did you say?
What did you
What
say?
did you say?
Said, what did you say?
Can everybody see this equation over here? T over 15? That's T over 15 right there. Okay? To the power of T over 15. Anybody here thinking of going into some kind of nursing in the medical profession or something like that? Maybe that's a popular, Haley maybe? Okay. Yeah, that's a very popular vocation. And it's really, this is a good school for it in that we have like a CNA certification and so forth. So, yeah. And this kind of level of algebra that a nurse would have to be concerned with, like a half-life of a dosage,
Or, yeah.
which is what that is. Doesn't say
I'm not
half-life.
good doing this, I just guess.
It doesn't say half-life there, but that's what this is. It's a half-life exponential decay.
Great, you show so much of it.
I really do. I don't understand that.
It's, you just look at it and you just plug what you think it would be.
How do you, like, get to that little point? Like, once you get the windows and everything, how do you get to that point?
Why? Wait,
Trace
what?
five,
Okay, some of you are talking through this thing a bit right now, which is good.
Orange mango.
40.5.
So this one here we have, looks like Bryce.
Let's do box.
Alright guys, one more question.
So Bryce, what'd you do on this one?
I did 50 equals 325, one half, and then.
Okay, so you set these two things equal to each other.
Yeah.
So this thing equals that, so you replace this
With that, yeah.
with that
Mhm.
and just plug that in, right?
Yep.
So like y1 equals 50 maybe,
Yeah.
y2 equals 325 times 1/2 to the power of x over 15. Is that how you did it? So let's put that in our calculator, see what that looks like. So 50, oops, I put 20 there, 50 equals, make sure I get this right here, 325. Power of, put x over 15, right? So what did you do next?
I'm still trying to figure out the window.
Are you?
Yeah.
Okay, well, let's talk about that a little bit. Bryce says he's trying to figure out the window. What's going to be, like, in these things here, I don't know what the x value is. Sometimes I just leave the x value where it was last on the calculator. But what about the y value? What clues do you have here from the y value?
It's gonna be 50. It's like the highest it's gonna be is 50.
Well, I'm going to say the highest it's going to be is 325. Because we're coming down, and remember we're starting there, this is our initial value, so we're coming down from 325. Now eventually we're going to get to 50, right? So, but this way, now for an exponential decay thing, which this is, you could set that as a max. That's going to be your y-intercept, right? And if you just put it around 50, you're going to be okay. But here, you know you're going to be able to see everything if you set it for that. And I don't know about the x value.
I would put it at 50.
Yeah, you can put it at 50. I'll just leave it at 40 since it was already 40. So we'll just see what happens. Maybe that'll be enough, maybe not. I don't know, we'll see, right? So yeah, it looks like 40 may or may not be quite enough. And if I do this here, I might actually get an error message. Yeah, see, error message, no sign change. So if here, what I have to do is I have to make some kind of, I mean, it's almost there, but now we'll probably be good, right? Yeah, that's clearly right. Second trace 5, enter, enter, enter. So 40.5, right? So 4.507. 40.507. So that's going to be about what? About 40.5 minutes, right? 40 and 1/2, that's minutes, right? Minutes, 40, about 40 and a half minutes. Does anybody know what some of you might occasionally consume caffeine as part of, yeah, coffee or energy drinks and so forth? Do you know what the half-life of caffeine is in your body? Anybody have an idea? It's supposed to be 5 hours, about 5 hours half-life of caffeine.
I saw that somewhere.
All right. So you go ahead and do number 20.
Me too. I can't get it.
So you're not,
That
I'll
is
just
easy.
finish your control.
I'll come back.
Okay.
All right. Okay, we got number of farms in Iowa. Is this an exponential decay or exponential growth situation? How can you tell exponential decay?
It's less than 1.
Yeah. You have a base between 0 and 1. That's your exponential decay.
I can't.
Here the units are something that have to be dealt with. This is going to be Braden or Chloe. It's Chloe. All right. I'll save this for tomorrow.
Second, trade, Rob.
Okay. What do we get for this one here?
Well, I did 80,000 equals 119 times 0.987 power t.
So 80,000 equals 119 times 0. Looks like we have a fly coming on. Right? You see her fly? The fly right here.
Why?
Kill it.
Oh,
It's a moth.
oh no. Oh, what?
I need Noah Bajork to the cafeteria.
That's pretty cool.
Okay. I don't know if I caught him. Well, maybe they did, maybe not. I don't know. Here we are. All right, go ahead.
And then I flipped that, of course, into my, what do you call it? No,
Okay with it.
I forgot.
Y
You said it's
equals.
Alexi and I forgot. The y equals, what did you call it?
Oh, the function editor, yes.
Function editor, there it is.
So 80,000
Yeah.
equals 119 times point, was it 987
Yep,
to the power of
T.
t?
And I tried setting up a window, but I can't quite find it.
Yeah, I can't either.
I've been looking for the
So, in the problem,
It says in thousands, so I did.
Yes.
In the thing, it says that it's by the thousands of years.
Uh-huh.
So wouldn't you do 80 instead of 80,000?
Okay, let's take a look at that again. Let's make sure that's right. That might be right. They'll say the number of farms in thousands can be modeled by, right? So we have like a unit conversion issue, don't we? Because we have so really to convert this to what,
And
so this is going to be equal to like 80K, right? 80K. So this is going to have to be 80 over here, right?
And then with that, I got 34,
So now it's going to be easier to adjust for a window.
Yep.
Yeah, what's your window going to be, like your Y window? What would you choose for this?
Negative 1,000. Negative 1,000.
You can go from 0 up to 200 or 120 or something.
I just kind of left my window the way it was.
Oh, really?
Yeah, so it's 34.
So your window was okay that way it was here?
I don't know about that way, but.
Okay, so you left it like this?
Maybe, I don't know.
Yeah, okay.
Try that.
So now we have everything here, right? 0.987, let's make sure that's right. Yeah, that's right. So I'm just checking, double checking. So this is going to be 80, right? Let's fix that. So we're going to delete. There we go, we ought to be good now. Okay, that looks okay, right? Second trace 5. So how many years?
31 years.
By, so it would be T equal 30.347. That's going to be years. So it'll be what, 1980 plus 30, what are you going to add, 31? The 30, that'd be 20. So that'd be by year 2011. How accurate would that prediction be, do you think, out in the future, 30-some years? You think that'd be pretty accurate? I mean, if you had to go, sometimes you can make predictions like this, but you have to realize the unreliability of that kind of prediction that far out. So anyway, we'll just leave it there today. Thank you for your work.